You can share AWS resource. You can share AWS resources or resource information between stacks and apps. Now it can be done in two ways. So you could have different stacks which are part of the same app, but there's also a possibility where you have different CDK apps which are sharing resources or resource information across different CDK apps. Now there are three possible approaches that you can utilize to achieve this. The first one is using the AWS SSM parameters to share information across different apps. The second option is using the class CFN output construct to share information again across apps. So you can see here we are using the CFN output, and earlier we had discussed when the prefix is CFN, that means it's a level 1 construct, and ideally we should not be using a level 1 construct. So that's why it's not a very elegant or native CDK solution, if I may say so. That's why we mostly prefer the AWS SSM parameter store in most organizations. And then the third possibility is create a multi-stack app within the same app. So these two were across apps, and this is creating multi-stack within the same app and then sharing resources or resource information. Now let's go ahead and see what we're going to build. So in this lecture, we're going to look at sharing of resource information across apps using the AWS SSM parameter store. So what we're going to do is we're going to imitate, say, a real organization, and say we have a cloud enablement team that is going to create a VPC as part of the network stack in a CDK app. And then once it's created the VPC, then we're going to create AWS SSM parameter store and store these VPC configuration details in this AWS SSM parameter store. Since we're going to create this AWS SSM parameter store as another CDK app, this will be a different CDK app. Then finally, we are going to assume that we have an application team which wants to deploy an EC2 instance. And for creating this EC2 instance, it will need a VPC and subnet. And that information it is actually going to get from this AWS parameter store. And again, this is another CDK app. So this is how we're going to learn how to share resources and information across three different apps. Okay, now let's go ahead and create this network stack. So I've created a folder called network on my local drive, and then I'm going to open this using the Visual Studio Code editor. So I'm just going to create a folder called mkdir, and I'll just call it as network and cd network. Now I'm going to initialize this CDK app. Okay, I waited a few minutes and now you can see it's complete. So let me just work here. And if I just go to the left folder, and this is my network stack. So I'm not going to write this code again for creating the VPC just to save time and not be repetitive. So I just opened the code that I already had from the web server use case. If you remember, this is what we had imported EC2 for creating the VPC. So I'll just import the EC2 construct as we had done earlier. And then I'm just going to copy this code for creating the VPC and subnets. Okay, so our name is demo VPC. So let's just change the name a little bit, maybe call it demo VPC1, and everything else I think we can let it be as it is. So let me do CDK deploy. I'll just pause the video till this is complete. Okay, I waited a few minutes and you can see now the stack is complete. So if I go to CloudFormation service and let me look at stacks, and you have the network stack and resources. And you can see all the resources that have been created as part of this VPC. Now what we're going to do is we're going to use this VPC ID that we have here. If I just click on this, so you can see the demo VPC1 that we created here, and this is the VPC ID. So this is what we're going to store in our SSM parameter store. Now let's go ahead and create that SSM parameter store using AWS CDK. So now I've just created another folder SSM, and I'm just going to open it with the Visual Studio Code editor. So I'm going to mkdir SSM, cd ssm and just do a clear. I will initialize the app and I'll just wait a few minutes till this is complete. Okay, now this is complete, so let me just do a clear. And before I proceed ahead, I just want to show you a quick guide that I have created for using the approach one using SSM parameter store. So first you create the resource in the CDK that needs to be used by other stack, such as VPC in our case. So we're storing the VPC ID in our case. Second is create the SSM parameter store using CDK and store the values in the SSM parameter store. So that will be the VPC or VPC ID in our case. And then you read the values from the system manager parameter store in the CDK app that will consume this VPC ID, like in our case, EC2 install. Okay. So we've already done the first step. Now let's complete the second step, which is create the SSM parameter store key value pair to store VPC ID details there, not really a SSM parameter store because SSM parameter store is already there. Okay, let's do a quick search. So I just type AWS SSM CDK and let me go to this module and see what needs to be imported. So you have to import AWS SSM. So let me do that. So I will just use the default code, and in place of SQS we have to write SSM. Okay, here it is. So our code goes here. So we'll say SSM parameters, and then we can say const, and we can say SSM, or let's say demo SSM, and then what we imported was, let's call it SSM. Okay, so we'll say here SSM, and now let's go ahead and look at the documentation. So earlier we discussed about different types you can use: string parameters, string list parameter, secure string. So we'll just go for string parameters. And now let's look at the construct props. So only mandatory thing is the string value. Everything else is optional. So maybe we can have a parameter name and string value. And string value is just a string. Let's go here, and instead of this Q, we'll have the string value. So you have string list and string parameters. So this, again, this is the scope. So we'll say SSM parameters, and then, okay, let me just get rid of this default value. So we see that the only mandatory value is string value. And this string value is actually this VPC ID that we need to store. But we also need the parameter name. I mean, it's optional, but it will give a default parameter name. So maybe we can give a parameter name. If you remember, when I was showing you the AWS SSM parameter store, it is in form of key value pair. So the name would be parameter name, the key would be parameter name, and the value will be string value, what we are going to store. In our case, it is the VPC ID. So let's say parameter name, and parameter name we can say as demo VPC, and then we have the string value, okay, and that will be our VPC ID. So you can just copy it from here. Okay, I think that's pretty much it. So once we run this code, then we'll have a parameter named demo VPC ID and the value as what we have given here. So this can then be used by EC2 instance to launch in this particular VPC. So let me do CDK deploy, and I'll just wait for this to get completed. I'll just pause the video. So I waited a few minutes. Now you can see this stack is complete. Now if I go to CloudFormation, and you can see earlier we had the network stack. Now we also have the SSM stack. So if I go here, and this is the SSM parameters that we created. If I go to this demo VPC ID, and that's the name, parameter name that we had given. If I go here, you can see this is the demo VPC ID parameter name that I had given, and here it's created. So this is parameter store, and And this is a demo VPC ID I had created, and this is the value of this VPC ID. So ideally, this is the format it should be created in, but let me do a redeploy so I can quickly redeploy. So let me quickly modify this and say VPC slash demo VPC ID. Okay, now this looks good. Let me do a CDK deploy. Okay, I waited a few minutes and I think now the update is complete. Let me do a refresh and you can see it's been created here. So if I just click on this, this is our VPC ID and this is the parameter name. Now if I go to my step-by-step guide, you can see we have completed the step 1 and we completed the step 2. Now in the next lecture, we're going to create an web server using these configuration details. Hope this lecture was useful. Thank you. Now, if I go to my steps guide, you can see here, first we created the network stack, and as part of the network stack, we created the VPC and its components. Now we have created the AWS SSM parameter store using CDK and then stored this VPC ID as a parameter in this SSM parameter store. Now the third step that we have to do is we have to create another CDK app and launch an EC2 instance using this particular VPC ID, which will be referenced from the SSM parameter store. And that's how we will share resources across different apps. So I've just created a new blank folder web server. So I'm going to open this. Okay, now I have opened this folder here. So I'm saying mkdir web server and cd web server. And then I'm going to initialize this app. Okay, I'm just going to wait a few minutes till this is complete. Okay, now this is complete. So let me just go to this lib folder. Now what we have to do is we have to create the EC2 instance. So we had already done that as part of our use case on web server. So what I'm going to do is I'm not going to write the code again to save time. I will just copy the same code and then make changes to that code. You can see the imports that we have. So I'm just going to do the same imports. Okay, and let me also copy the code. So I will not copy this VPC code because that we are going to import. The rest of the code I'm going to just import. So from here, security group. Okay, so you can see it's giving me some error on the demo VPC because earlier we had created the VPC as part of the same stack. Now we're going to import that, and those are the two errors that I'm getting. I just also have to copy this user data and I can just name it as userdata.sh. So let me create that file. So I'm just going to copy this user data file from the code that I had earlier. Okay, I'm just going to paste this user data file, and as we discussed earlier, it's a very simple file which will give some message. So maybe instead of hello from AWS with Rahul, and let me say multi-stack. So it's pretty much similar to what we had done when we were creating the web server use case. So I'm back here. So there are a couple of more things we have to add. One that we have to add is importing the SSM parameter store. Right, so let me do that because we're going to retrieve the value from the SSM parameter store. Okay, so let me call it SSM. Now, how do we retrieve this value when we're creating the EC2 instance from the SSM parameter store? So you can see here, we can use string parameter dot from string parameter name, and this reads value at deployment time. But what AWS documentation is saying is it is supported only for limited AWS services when you do a deployment time. The other option is to use string parameter dot value from lookup, and this is done at synthesis time, and this is supported by most services. So I think unlimited is not correct. It is supported by almost all services. So this is what we're going to use. So once we retrieve once, these value will be cached in the CDK .json. I'm going to show that. The other thing you need to do is for this lookup to work, you have to explicitly provide the accountant region information. Otherwise, it will not work. So that's what we're going to do. So we're going to use this SSM dot string parameter value for string parameters. And this is highlighted in this AWS documentation, so you can read a little bit more from there. Okay, now we're going to say retrieve from SSM. So this is how AWS defines. So you have to use whatever you imported, then string parameter. If it's a string parameter of a secure string, then you have to use something else, and then value from lookup, and then the scope and the name of the parameter. So let's do that. Let's say, and we'll say VPC ID is equal to new and SSM, because that's what we are importing here. Then we are using string parameter, so string parameter, and then we're using value from lookup, and then we'll say this comma and the name of our parameter. So let me just go here, and this is the name of our parameter. So we'll go here and paste it. Okay. Now we have this VPC ID value. Now that we have retrieved this value of VPC ID from this SSM parameter store, next what we need to do is, if you see here, this interface VPC lookup options. So properties for looking up an existing VPC. So if there is an existing VPC, whether it's default or non-default, this is how you need to retrieve it. So you can see here. So maybe I'll just copy it from here to retrieve this value, and let's just put it here. So I'm just going to slightly modify and say demo VPC, and then EC2, we are importing it as EC2, and then we have the VPC from lookup. Let's say new VPC, and is this default? So this is not default, so we'll say VPC ID. So it is the ID of the VPC, because we are retrieving this VPC from the ID. So there are different ways of retrieving. You can also retrieve it through, say, VPC name. You can see here. But what we had done is we had stored the value of the VPC ID. So we're going to retrieve it using the VPC ID. And that VPC ID we have from here, right? So we'll say VPC ID. Okay. Now we have the value of our VPC, and now when we create the security group, it needs a VPC, and this is our VPC. So this is our demo VPC. So if we go over here and say demo VPC, and now you can see it's not giving me an error. Okay. So now to quickly summarize what we have done, first we retrieved the value of our VPC ID from this SSM parameter store. Then AWS allows you to retrieve the value of existing VPC through this VPC lookup. And with VPC lookup, you have two options. Either you can retrieve it using the VPC name or the VPC ID. In our case, we retrieved it using the VPC ID. Okay. Similarly, now since we are creating the EC2, we have to define what is the VPC name of the VPC that we're going to use. Again, we are going to one which we have created here, demo VPC. So we'll say demo VPC. Okay, now I think you can see all the errors have gone. So it looks good. The only thing, as I said here in the documentation, so we have to explicitly provide the accountant region information. Okay, so if I go here and go to this bin, so I have to remove this. And region is okay, US East 1. You have to provide the account details. If you are deploying to a different region, you have to define your region. Okay, so if I go here, copy this, and I'm going to change this. Okay, I think everything else looks good. So hopefully this will work. So I'm going to do CDK deploy. I'm just going to pause the video for a little bit until this is complete. So it's asking me about the security group, so I'll say yes. Okay, now this web server stack has been deployed. Let me just go to the cloud formation, and you can see the web server stack here. Let me go to the EC2 instance and see if it works. So here are the resource. You can see this EC2 instance is now running. So if I just click on this EC2 instance and just look at the VPC that it has been deployed in. So let me go to networking. And here you can see the VPC ID. So it is D69 demo VPC1. And now let's go to our parameter store. So it's D69. So you can see here, this is our parameter store, and this is the parameter name, and this is the value D69. So this is exactly deployed in the VPC that we had stored in our parameter store. Now let's just go ahead and run this VPC and see if it works. I will just copy the public IP and let me say HTTP, and this is my IP. And you can see I'm getting this message, hello from AWS CDK course on Udemy with Rahul and multi-stack. Hope this lecture has been useful. Thank you. Okay, now the second approach for resource or information sharing across apps is using the CFN output construct. It's a CloudFormation feature to share information between stacks. So you export a stack's output value and then import it in the different stack. So it's basically an L1 construct. As you can see, there's a prefix CFN. So you'll use the CFN output to export the value and then use the function import value in the app that requires to consume information related to the service that is being created in a different app. So we'll continue with our web server stack that we had used in the approach 1. So now what we'll do is we'll create a security stack, and as part of this security stack in a different app, we're going to create an IAM role for EC2 instance, and then we're going to export that IAM role value, which will be imported by the web server EC2 instance that we have. So now let's go ahead and do that. Okay, I've created a security folder on my local. Now I'm going to open that. Okay, so and let's call it security because it's security stack. So security, and now I'm going to initialize the app. I'm going to pause the video till this gets complete. Okay, I waited a few minutes. Now this is complete, so I'm going to do a clear. Now earlier in the initial few lectures, we had created an IAM role. So I'm going to use the same code because I just want to save time and not repeat the same thing. So this is the code from that lecture. So I'm just going to copy this, or rather I'll just copy this. And let me just go here. Now let me just copy this part of the code, IAM role. Okay, now let me just get rid of this boilerplate code. Now you can see this one we had created for lambda function. So now because we're going to create it for EC2, so we have to make some minor modifications, and you can see here demo IAM lambda role. So maybe I'll just change it to EC2 role, and then demo role for EC2, and here you can see assumed by, and here we have the service principal. So because this was for lambda, so here it was lambda, but our service principal is not lambda now, it's EC2. So we'll just change it to EC2, and then for the role we'll just keep it same. It's basically gives us full access to S3 bucket. This is pretty good now. So what we need to do is let's just go ahead and deploy this. So I'll say CDK deploy, and I'll just pause the video for a little bit. Okay, I waited a few minutes and now this is complete. Now let me go to the CloudFormation. So you can see the security stack here now. I go to resources. So this is the demo IAM EC2 role. So that is what we had defined here. Okay, good. Now this is good. Now what we need to do is we need to export this value. And for that we discussed we have to use the CFN output construct. So let's just say CFN export. So let me just go here to the left and move this a little bit. So let's say CFN output. Now let's go to the documentation, CFN output CDK v2. So let's do search, and if I go here, okay, now you can see the class CFN output here. So basically you don't need to import anything, and if you just take a look at the properties, the only mandatory one is value, which is a string. The value of the property returned by AWS CloudFormation describe stack command. Now you can see the properties here. So we have the value, which is the mandatory one. It's a string. It is the value of the property returned by CloudFormation describe stack command. So this one we need, and then we can just put description, the string type that describes the output value. So what is the value of the output? And then export name is again not a mandatory. The string, the name used to export the value of this output across stacks. So now let's do that. First, we'll just define the value. So I will say asked and say, and that will be equal to new CFN output, and then I will say scope, which is this, and demo IAM, and then we need to define the properties. So I'll just remove this. So the first property we discussed was value. So for the value, we'll have this IAM demo role that we have created. So I'll say IAM demo role, and then if I just press full stop, it will show me all the properties that I can import, and maybe I will just import an ARN. So I can import a role ARN. I mean, there are a lot of things you can actually import: ARN, ID, name, etc. So I'll just import the role ARN, and which is going to look like this. So this is the demo IAM role, EC2 role that we had created. And if you see the ARN, so this is what we are going to import, and that we are going to use for our EC2 instance. So now this is our demo ARN. So I'll say next, and then we will just description and say IAM role for EC2. And then we can additionally have the export name. So if I go to documentation, you can see here export name, the name used to export the value of output stacks. So we'll say export name, and we'll say demo IAM role for EC2. Okay, now this looks good. Okay, now let me go ahead and do a CDK deploy. I'm just going to pause the video for a little bit. Okay, now this stack has been created, security stack, and then you can see in the output section, security stack dot demo IAM. This is the ARN that has been created. If I go to CloudFormation and if I just do a refresh, in the outputs, we can see this demo IAM, and this is the value, this is the description that we had given, and this is the export name. So demo IAM role for EC2. You can see this is the export name and this is the description. Now we have to import this in our web server stack. So now let's just do that. Now we have to import this in our web server stack. So now let's just do that. So I will just go back and I will just open this web server stack. Okay, now I have opened the web server that we used in the approach one. You can see here that we have imported the VPC ID. Now let's take a quick look at what we need to do next. You can see we created the security stack, and as part of the security stack, we created the IAM role for EC2. Now we're going to import that role and attach that to the EC2 instance through the web server stack. Okay. Now we have this code. The first thing we have to do is we have to import the IAM construct in this module. So let me do that. So I will just copy this and I'm just going to change this to IAM. You can see here, and let me call this as IAM. Okay. Now what we have to do next is we have to import that IAM role ARN so that we can use it in our EC2 instance. So the next thing we're going to do is import the IAM role. Okay, so as part of that, what we're going to do is we're going to say, so I can say demo IAM. Good. Okay, now if I go to the documentation, so I have opened the IAM role documentation here. So you can see we imported this IAM, and then now have gone to the role construct. So in the role construct, there is a special method which allows you to import an IAM role using the AR. So let's go and search for that. So if I do AR and search, okay, you can see here this static from role, scope ID, and a role AR. Import an external role by an AR, and that's what we are doing. So if I just go a little bit, so yeah, this is the one. So this is how it is implemented. The method name is from role ARN, and then you have the scope, ID, and the role ARN. So you can see here, if the imported role ARN is a token, such as CFN parameter dot value string or FN import value, and also is referenced by as a path by this. So this is what we're going to use. So let me just go back and say IAM dot role, and then let's see what's here. It says from role ARN, and that's what we're going to do, from role ARN. I think this is the one. Okay, and then we're going to say this, comma, say IAM role import, and then now we have to import the value from the previous stack. Okay, so let's go back to the documentation, and it says fn dot import value. So I'll say CDK fn dot import value. So here it is. Now we have to provide the export name here. So if I go to CloudFormation stack, and this is my CloudFormation stack for security, and if I go to outputs, you can see the export name is here, demo IAM role EC2. So I'm just going to copy this and just paste it here. Okay, it's giving me an error, so I think it's a string. Let's try that. Okay, good. I think that error is gone. So next what we have to do is, in the EC2 instance, we have to define the role. So there is an attribute called as role. So if I just go here and let's say role, you can see the role here. And now this role is the IAM role. So I can just use what I have here, demo IAM. So let's say demo IAM. Now we can see we're good. So the role we have for EC2 instance, we have attached, which was imported from the different stack. So I think everything looks good. So I'll just go to the terminal and then do a CDK deploy. So I'll just do a cd web server and then CDK deploy. So I'll just pause the video till this stack is deployed. So it's asking if I can allow security related changes. So I'll say yes. Okay, I waited for about 206 seconds, and now this is complete. So if I go to CloudFormation and let me go here, let me just do a duplicate of this, and let's go to this web server stack. Let's go to the resources, and let's see demo EC2, and let's see if we have created that IAM role. So if I go here to this EC2 instance, let's see what is the IAM role that's been attached. So you can see demo IAM EC2 role that's been attached to this EC2 instance. And if I go to the security stack, you'll see that this is the same role that's been created. So you can see here demo IAM EC2 role, and that's what's been attached to this EC2 instance. So now hopefully it's clear how we can share resources across the apps using the CFN output. And if you want to read a little more, here is a URL that you can access at your convenience. Hope this is useful. Thank you. Now let's look at the approach 3. Till now we looked at sharing of resources between different apps, but now we're going to look at sharing of resources within the same app. So you will have multiple stacks but within the same app. Now before we go on to the implementation of multi-stack, let's try and understand why there is a need for multiple stacks within the same app. Now let's take an example of a web application. It will be a 3-tier architecture. So you'll have multiple AWS services supporting that 3-tier architecture. architecture. So you could have security services like IAM role, security group. Then on the app tier, you could have EC2, Lambda, or containers. Then on the database or storage side, you could have an S3 bucket or RDS DynamoDB. Now for each of these tiers, you might want to have different access control policies. Like for the security services, you might want to have more fine-grained control. Or for the database stack, when you delete the stack, you might want to take a snapshot of the database, which might not be required for security services or app tier. So that's why you might want to create a multi-stack within the same app. Now let's take a look at this diagram. So here you can see we have one CDK app, and within that we have three different stacks. So you have a security stack, which would have an IAM role or security group. Then you could have a storage database stack, which would have S3 bucket or any of the databases, say DynamoDB or RDS. And then you could have an app server stack where you have the Lambda function or EC2. Now in the example that I'm going to demonstrate, I'm going to show you how to create a security stack which would have the IAM role, and then also maybe create a storage stack which will have the S3 bucket. So within the same CDK app, we'll create two stacks, one for the IAM role and one for the S3 bucket. So before we get into hands-on, a few things I just want to highlight. So in AWS CDK, you can create apps containing any number of stacks. So you can have multiple stacks. That really depends on your strategy based on what we just discussed. Then each stack would result in its own CloudFormation template. So in this case, so you have three stacks. So you will have three different CloudFormation templates that will be generated. And each stack in an app can be synthesized and deployed individually using the CDK deploy. So either you can use CDK deploy -- all, which will deploy all the stacks that you have within CDK, or you can do the CDK deploy and give the stack name, and will just deploy the particular stack that you have given the stack name for. Hope this theory helps. Now let's go ahead and do some hands-on. Okay, now let's see this in action. So rather than writing the whole code again, I have taken the same use case that we had deployed earlier using the API gateway, Lambda and S3 bucket. So what I'm going to do is I'm going to create two stacks, one with IAM role and another one with S3 bucket. So I'll get rid of the rest of the code on API gateway and Lambda function. And I'll just remove this policy as well. So I'll just create an IAM role in one stack and S3 bucket in another stack. Okay, I'll just create a new file here. So I'll say new file, and I will call it as S3 stack.ts. Okay, so now what I'll do is I'll create another one, new file, and I will name it as IAM role -stack.ts. Now what I will do is I will write all this code individually in these two files to create separate stacks. So let me just go here, and let me just for now copy this whole thing, and let me go to the IAM role stack, and I just paste it here. So I will have only the code that is relevant to the IAM stack. So I know API gateway or Lambda function is being created. So I'll just remove this code. I'll remove the S3 because in this stack we are only creating the IAM role. So rather than naming this infra stack, I will name this as IAM role stack, and you can name it anything you want. And then I will just get this S3 bucket code out of this. I'll just change the name because the role name might already be there. So let me name it at 09. So we have a unique role. Okay, I think this looks pretty good. Now let me go to the S3 stack. So I will do the same thing. I'll just paste the same code, and I will only use the constructs that are relevant to this, which is only the S3. Okay, so we know the core module and then construct and this S3. Let's name this as S3 stack. S3 stack. Okay, and I will get rid of this IAM role from here. And I will name this uniquely. So let me call it as 09, so that we have a unique bucket, maybe it's another 09. Okay, now this looks good. Now the change we have to make is in the bin folder. So I'll go to the bin folder, and I'll go here. So here we only had the new infra stack. So now we are creating two stacks. So I'll just do copy and paste. And the stack that we have now is not infra stack, but let's go and look. So we have the S3 stack. So I will just replace it here. So I'll say S3 stack. And here I will say I'm role stack. Role stack. Let me just cross verify whether that's the name of the stack. So I am role stack. Okay, here. Okay, now what we have to do is we have done the import for infra stack from this particular file path. So instead of this, we have changed the file path now. So this is instead of the infra stack, I have the I am role stack. And this we are importing from the lib infra dash stack. So we are importing from I am role dash stack. So I will just change this role and it gives me the option. This is the file name that we have here. Okay. And then we are also importing the S3 stack. So let me just change this. S3 stack from, and this is the name is S3 dash stack TS. Okay. So S3 stack. Okay, I think this looks pretty good now. So this is my logical ID. So let me just change this. So let me call it S3 stack. And let me change the stack name here to I am role stack. Okay, I think this looks pretty good. Now we should have two stacks. Okay, now let's run some CDK commands and do a build. So first I will do cd infra, and then let me go clear. Let's do CDK synth. Okay, it did the synth. Now you can see that it is showing two stacks, I am role stack and S3 stack. So we can also do CDK list to list all the stacks. Okay, it's showing me the two stack, I am role stack and S3 stack. So let me do a clear. So now you can see you have two options to deploy. If you want to deploy both stacks together, you can use CDK deploy dash dash all, or you can do CDK deploy stack name. So let's deploy them individually. So I will say CDK deploy, and I'm just going to say S3 stack first. So it will just deploy the S3 stack. It will not deploy the IAM role stack. So I'll just pause the video for a little bit. I waited about a minute and now you can see it has deployed the S3 stack. Okay, now let's check it on the CloudFormation. So you can see this S3 stack has been created, and let's just take a look at the resource. And balance status 01225.909 is, that's what our S3 name was. You can just quickly check in the stack. So this is our bucket name 0909, and you can see this has been created. But now at the same time you can see the IAM stack has not been deployed because we have not done that. So now let's deploy the IAM stack. So I'll do a clear. So let's do CDK list. It will show us all the stacks. It shows the two stacks. Now let me just say CDK deploy IAM role stack. So I'll just pause the video for a little bit. Okay, it's asking me if I wish to deploy these changes. I'll say yes. So I just waited about a minute and now it has deployed the IAM role stack. So let me go to CloudFormation, and you can see this IAM role stack has been created. So I go here now to the resources. You can see this IAM role has been created. Okay, so you can see this is how you can do multi-stack deployment. So there are two separate stacks that have been created. And now what you can do is you can set up separate stack level policies for both these stacks. And what you can also do is you can update the one stack without impacting the other stack. So now let's just take a look. So now what I will do is I will just destroy the IAM role stack, and you will see that there is no impact to the S3 stack. So let me say CDK destroy IAM role Let me just take a look. The name is correct. I'm role stack. Okay, I think this looks good. So it's asking me if I want to destroy this text. I'll say yes. So you can see this IAM role stack has been destroyed. And if I go to CloudFormation, you can see it's no longer visible. Only S3 stack is there, and there has been no impact to the S3 stack. So hope this is clear. So in this lecture, we're going to learn about 10 best practices on AWS CDK that I have learned based on my cloud migration experience. So the first thing is we need to separate out the infrastructure as code and application code into separate folders. And this is something we have done all along. So you need to create two folders, infra folder, where you have all the infrastructure related code. Then you need to create the services folder where you have the application code. And alternatively, you can also create a test folder where you have the test cases. But definitely you need to have two folders for infrastructure and application code. The second one is on single or multi-stack deployment for an end-to-end application. And we looked at both the scenarios. We created a single stack and multi-stack. There is no right or wrong answer for this, but the approach that we followed was that we created two separate repos, one for sensitive AWS services such as IAM role, security group, and NACL, because you want access to those repos for a limited number of users because they are sensitive AWS services. The rest of the AWS services that were created for that end-to-end application would go into a separate repository. And then for each repository, you will create a separate stack. So in majority of the cases, we had two repos and two separate stacks for an end-to-end application. On one hand, all the sensitive AWS services, and on the other hand, the rest of the AWS services. So I also looked at AWS recommendation. What AWS recommends is that you can optionally look at separating the stateful resources like database in a separate stack if you want, and then have the stateless resources like web layer, app layer resources in a separate stack. The reason is then you can manage policies at the stack level. So you could have turn on termination protection on the stateful stack, and then also define the resource retention policy based on the kind of resources that you're using. The third one is the resource naming convention. So there are two possible options on how you can name a resource. So let's consider an S3 bucket. So either it can be an AWS generated resource name or physical name of that S3 bucket, or you can hard code the value of S3 bucket name. If you remember in the CDK constructs, it's an optional attribute. Now what AWS recommends is that you do not hard code the value. And the reason is that say you hard code the value and you run it in the dev environment. So you create an S3 bucket. Then when you move to production, and if you use the same hard coded value, there's going to be a conflict because S3 bucket has to be a globally unique name. So that's why AWS recommends that you use AWS generated physical name for an AWS service. But based on my experience, what I've seen is that usually it's a good practice to be able to correlate the AWS service name to the business unit and the application stage, etc., so that you can easily identify the resource. I know you can do it through AWS tags as well, but what I've seen is that it is mostly preferred to be able to give the physical name that will correlate to the business unit, application, and stage. So how we used to do the naming convention would be something like this. Saying I have to name an API gateway. So I will say business unit name, application name, stage, and then hard code this API gateway. So what will happen is I'll create a configuration file which I will use as an environment variable where I put the business unit name, the app name, and stage. And all these values are taken from this configuration file. So for each stage, it will be a unique name, but at the same time, you will be able to correlate which business unit this service belongs to, which application this service belongs to, and the stage. So that is what I have seen, but AWS recommends that you use a randomly generated AWS name from what I read on the AWS documentation. The fourth key one is that the logical ID of the resource, especially the stateful resource, should not change because it can have an impact on the service due to replacement. When we were creating the AWS services, we had to provide the logical ID. Now say for some reason you change that logical ID, and if you change the logical ID, that means that resource would be replaced. So there will be an interruption to that particular AWS service, especially in cases of stateful resources like database or S3 buckets. That can have an impact because then you are changing the AWS resource and there could be a service disruption. Similarly, for persistent infrastructure like Amazon VPC, this can have a catastrophic impact. So one thing we should always ensure is not to change the logical ID if we are updating our CDK code. So to summarize, if you are refactoring your AWS CDK code, then you should not make any changes to the logical ID. And you can also have unit test asset that check whether the logical ID of your stateful resources has not changed or remains static. So other thing you need to be careful is on the resource retention policies and log retention, especially again for storage services or persistent services such as S3, RDS, EFS in each environment. So what happens is there's a default policy, say for S3, when you delete the stack, the default policy is retain. So it will not delete the S3 bucket. So if you are deleting the resources in the lower environment, you have to look at what is the retention policy, because otherwise you're going to be charged if you delete the stack, but at the same time, the retention policy is retained. So the service will continue to exist and it could incur charges for you. Similarly, CDK's default policy is to retain all logs forever. So in production, if you are generating a lot of logs and you don't have a retention policy for logs, then you could accumulate a lot of charges. So you should take a look at resource retention policies and log retention policies for all your AWS services. The sixth one is application deployment and CI/CD pipeline is recommended to be in different AWS account. So what I have seen based on my experience that your CI/CD pipeline would be deployed in a different AWS account, and the applications or resources related to those applications would be deployed in a separate AWS account. So it's a good practice to deploy the pipeline in one AWS account and the application resources or AWS application services to be deployed in a different account. So another key practice I have seen is that you can create one repo across environments and then deploy using stage variables. So you create a single repository for your infrastructure as code and application code, and then deploy the same code to different environments such as dev, QA, or prod. And you don't create separate repos for each environment. So you have a single repo, you deploy that to a particular environment, say dev, and if everything passes, then you push the same code to QA and then to prod. The other practice that I've seen is use secrets manager or SSM parameter store for storing sensitive values. So you don't push details such as username and password for RDS into your code repo. So you use the secrets manager or SSM parameter store where the username and password be retrieved, and then you can access the database. Then another key practice that you will see across large organization is creation of custom constructs based on the architecture patterns aligning to their business domain. So what it means is that most large organization will create their own patterns to encapsulate all the resources and their default value inside a single higher level S3 construct that can be shared. So what this means is it can range from a very simple service. Say if you're creating an S3 and you want only encrypted data in an S3 bucket, so you can write a wrapper around the existing CDK module, and all the developers within the organization use the same construct. So this is a very simple example. The other one is where you have common architecture pattern. So you can create a construct around that architecture pattern, which then can be used across different applications. And how this helps is that you need very limited knowledge for your developer to implement that pattern. So this can really speed up development and create standardization across the organization. And then finally, you need to measure everything. You need to measure all the aspects of your deployed resources to creating CloudWatch metrics, alarms, and dashboards. You can also use CloudWatch and Elk OpenSearch. So based on the migration we did, we measured all the key metrics and then set up alarms and dashboard to monitor the resources at a real-time basis. We also use Elk OpenSearch to understand the common issues and how those can be mitigated to improve the reliability of service. So these are some of the common practices that I have observed based on my implementation. Hope this is useful. Thank you. Few learners wanted me to show how we can add termination protection using the CDK code. So what is termination protection and how is it useful? Basically, termination protection is used to prevent accidental delete of your CloudFormation stack. If you want additional protection against accidental delete of your CloudFormation stack and consequently your AWS resources, then you can enable the termination protection. So the termination protection can be enabled using the construct stack. So you can see the construct here, stack. And then what you need to do is you need to go to the infra folder, bin, and then within the infra.ts file, you need to add this attribute termination protection and then make it as true. Now let's go ahead and see this in action. So I will just copy this URL. Okay, now I'm in the CDK documentation and construct stack, you can see here. So what we need to look at is the construct props, and here you can see termination protection is basically a boolean whether to enable termination protection for this stack or not. Now I have opened the code for the S3 bucket that we had created earlier. So what we need to do is we need to go to this infra bin and infra.ts file. So I will go to infra bin and then infra.ts file. So here I'm going to add the attribute termination protection. So termination protection, and you can see already it's showing me autocomplete, and I will just mark it as true, and then I'll just do a save. Now I'll just go ahead and do a CDK deploy. Maybe I will just change the S3 bucket name. So let me make it as 17 July just so that it's unique. And I'll do a save and then do a CDK deploy. I'll just pause the video till it's deployed. Okay, now you can see this stack has been deployed. So if I just go to the CloudFormation, I'll just do a refresh. You can see this infra stack is here. And if I go to resources, and it's created some S3 bucket, etc. Now if I just go ahead and run the command CDK destroy, so it should ideally delete this CloudFormation stack. But you will see that it will give an error saying that termination protection has been enabled and that needs to be disabled before you can destroy the stack. Okay. So yes. So now you can see it's given an error saying infrastack destroy failed error. Stack infrastack cannot be deleted while the termination protection is enabled. Okay. So now if we want this stack to be deleted, what we have to do is we have to go back here, infra.ts, and then I can just say this as false. Okay, and I just do a clear here, and then I can say CDK deploy. Now this stack has been deployed, and if I just do a CDK destroy now, hopefully it should work. Now you can see it's saying infra stack has been destroyed. That's how you can enable the termination protection to prevent against accidental delete of your CloudFormation stack and resources. So hope this is useful. Thank you. In this lecture, we're going to discuss some common CDK commands and some not very common CDK commands. So let's go through them. So the first one is the CDK init app. We have already discussed this and used this extensively. So it initializes the CDK app. Then we have the npm run build. This is an optional command which does the build, but even if you don't use it, the CDK automatically runs this command. Then you have the CDK bootstrap, and bootstrap we learned it deploys the CDK toolkit in the staging stack, and is again a one-time command. Then you have the CDK synth, which synthesizes an AWS CloudFormation template for the app. Then you have the CDK deploy. I missed the C here. So CDK deploy, which deploys the stack onto the CloudFormation. Then we have the CDK diff. The CDK diff also we used. It compares the specified stack and its dependencies with the deployed stack or a local CloudFormation template and highlights what are the changes. Now below are some of the commands that we have not used. So we'll take a look at their definition and then implement them. So you have the CDK docs. It basically opens the CDK API reference in your browser. So let's take a look. So I have the S3 bucket that we created in the last lecture, so we'll just use the same one. So I will say CDK docs, and you can see it opens the documentation for CDK. Okay, now let's take a look at the next command. Next, we have the CDK list. So it lists all the stacks in the app. So let's take a look. Okay, now let's run this command. So I'll say CDK list, and you can see it's returned the infra stack. That is the name of our stack. So next we have the CDK metadata, which gives information about the stack metadata. So let's write this one. So let me say CDK metadata, and then we have to give the name of the stack, which is infra stack. So you can see it is given all the metadata related information regarding this particular stack. So the next one we have is the CDK deploy hot swap. So what this hot swap flag does is it deploys the AWS resources directly instead of generating the AWS CloudFormation change set. So this should not be used in the production environment because it doesn't deploy the change set for you to review and then deploy. It's directly going to deploy the changes, and there will be also a warning provided by AWS which recommends to use this kind of flag only in the dev environment and not in the production environment. So let's take a look. So I will say CDK deploy dash hot swap. And you can see it's giving me a warning. The hot swap flag deliberately introduces CloudFormation drift to speed the deployments. It should only be used for development, never use it for the production stack. So it's doing a build, and then now it's deploying without creating the change set. Okay, now it's deployed, so there are no changes, and that's what it's trying to highlight. Then finally we have the CDK destroy, which destroys one or more specified stacks. So if we don't want to incur charges after we have created the stack, we should always run this CDK destroy, so it destroys all the resources that have been created as part of our stack. Okay, I'm just going to work here. Okay, so I'm going to say CDK destroy. So it's going to take a little bit of time. So it's asking me if I want to destroy, so I'll say yes. So you can see now it's destroying the stack. Okay, the stack has been destroyed. So that's pretty much it on some of the important commands. There are a few more commands, but you're probably not going to use it. So it's best to stick to the commands that are important and which we are going to use frequently. Hope this was useful. So in this lecture, we're going to look at CFN output. What CFN output does is it outputs the value or the physical name of any AWS resources that we have as part of the stack. So where this is useful is that if you have large number of AWS resources, in some cases like S3 bucket, where the physical name is optional, you might want AWS CloudFormation to provide it a random name. In those scenarios, what you can do is rather than scrolling through and trying to figure out what is the resource name, you can go to this output tab in the CloudFormation stack and just see the name of that bucket name or EC2 instance or any other resource. So let's take a look at how we can do this through the CDK. So just to save time, what I have already done is I have initialized the CDK app, and what I'm trying to do is create an S3 bucket. So I've just done an import S3 from the AWS S3 module, and then I have just written here a variable S3 output, which will be new S3.bucket, which is our construct. Then we have the scope, and then we have the logical ID, and I have not provided any attributes. If you go to S3, let me just show you, and you can see all the properties are optional. So I'm not going to provide any property. And then what I'm going to do is I'm going to use CFN output construct to output the bucket name, which has been auto generated by CloudFormation. Okay, so to do that, we have to use the construct called as CFN output. Okay, so you can see here it is part of the core module, and the convention for this is new CFN output, then you have the scope, then you will have the logical ID, and then finally you will have the attribute. So there are four possible attributes that you can use, and only one is mandatory, which is the value. So the value of the property you are trying to output. So now let's go ahead and do that. So let me say CFN output, and then I will say CFN output S3 equal to new, and then we'll say CDK because that's the core model we are using, and I will say CFN or construct name output. Okay, here it is. And then I will say this, comma, CFN. I'll just say output bucket. And then I have to just provide the attributes. So we'll just provide the value attribute. So let me just go here. You can see value is mandatory. So this is the format it needs to be written. So I'll just copy it from here. And so the format for writing this is, you just get rid of this. Then you use the S3 output, which is the variable name of the resource that you are trying to output. So I will say S3 output dot. Then you have to provide what is the attribute that you are trying to retrieve or output. And in our case, if you go to S3, so we are trying to do the bucket name. So I'll just go here and say bucket name. Okay, I think I've just put two brackets here. That's why it's giving me an error. Okay, so everything looks good. Let me just do a CDK deploy. So I'll just pause the video for a little bit till it deploys. So it's still in the progress of building the assets, creating the CloudFormation chain set. Okay, it took about 42 seconds and now you can see the deployment is complete. Let me go to the CloudFormation stack and you can see it's complete now. It's created all the resources and the resource we had was S3 bucket. But if you now go to this outputs tab, you can see we had the logical ID as output bucket. Here, output bucket is the logical ID. And then we have the name of the S3 bucket that has been created, the physical name. And if I go to this resource and we can just check from there if that's correct. I go here and this is our physical name of the S3 bucket. And you can see this is the same one here. That's how we can use the CFN output to output the physical name of any AWS resources that have you created as part of the stack. Thank you. So in this lecture, we're going to learn about AWS CDK testing. There are two categories of tests that you can write for AWS CDK apps. So one is the fine-grained assertion test, and the second one is the snapshot test. Now, for fine-grained assertions, AWS CDK apps uses the AWS CDK assertion module and test framework like Jest for TypeScript. So I'm on the AWS CDK documentation and you can see this is the particular module that AWS CDK uses for writing the fine-grained test. So this is the assertion module. Now, what does the fine-grained assertion test do? It tests specific aspects of the generated CloudFormation template. So now let's assume that you have a requirement in your organization that all the S3 buckets that are being created should have versioning enabled. So what you will do is you will write a test using the fine-grained assertion where you define that any S3 bucket that you're creating should have versioning enabled as true. So when you write your code using the AWS CDK, it will generate a CloudFormation template when you run CDK synth. So what fine-grained assertion does is it matches the property that you have defined in the test with the code that you have written and the generated CloudFormation template. So it will match the two. If the property is true in both, then it will pass the test, else it will fail. So it does not test against the CloudFormation template that's been generated in your production dev environment. So even if you don't do the CDK deploy, it will still test out that property locally using the CloudFormation template that's been generated, if you remember, in the CDK out folder. And we'll take a look at it in more detail once we do the hands-on. So how is this useful? It is useful for detecting regression. So say you are making a lot of changes to your CDK code, and at the end of the day, when you run the test, it will make sure, like in our S3 example, that versioning enabled is true. Otherwise, those tests will fail. It can also be used as a test-driven development framework. So if you are aware of the test-driven development framework, basically what you do is in the test-driven development, you write the test first, then you write the functionality, and then you run the test case again. So for example, first you will write in the S3 bucket example you will write the test case where versioning is equal to true. Then you will run the test. It will fail because you have not written the functionality or the CDK code at that point in time which says versioning is equal to true. So the test case will fail. Then what we'll do is you will write that functionality. You will add that property in the S3 bucket where versioning is equal to true. Then you will run the test again, and then the test will pass now because it has the functionality. So that's the test driven development approach. This is also the most frequently used test in AWS CDK. Okay, now let's see how to test using these fine grained assertions. So I've just written a step-by-step guide. The first thing we do is we write the CDK code for AWS service being created with the required properties or attributes. So what I've done is, to save time, I've just written a simple code which we had created earlier for S3 bucket. So here I just have a simple S3 bucket with bucket name test demo 18/03/2023 and version true. So for now I have just written the code. I have not deployed this code nor I have done any CDK sit. So this is pretty much straightforward. I just written the code and that's it. The next step we do is we write the CDK test for properties that need to be tested for AWS infrastructure service using assertion module and jest tool. So as I said, we are going to test out two properties, the bucket name and version for this particular scenario. So what I will do is I will go to this folder test here, which gets generated automatically as a boilerplate code. So I'll just click on this and you can see we have some boilerplate code here. I will modify this boilerplate code and I'll explain how this test works. So I'll just remove this. You can see here, the first line is pretty clear. You import the core AWS CDK lib module. Then the second thing you do is you import the template from this AWS CDK lib assertions. So earlier we discussed that it uses assertion module for testing, and then you import template construct. So if I go here, so you can see this is the module that I'm importing, and what I'm importing is a particular construct called template. So you can see here the template class includes a set of methods for writing assertion using CloudFormation templates. Using one of them, template dot from xxx static method. So I'll show you which are the various methods. But for now, we're just saying that we are going to import the templates from this module. Okay, the third thing we're going to import is import everything as infra from this particular file path. So this particular file path is the one which we have created here. Okay, so that's pretty straightforward. Now let's modify this code. So here in the line 7 you have test, and you can just give a comment here. We are not testing out the SQSQ, so we'll say S3 testing, and then we leave everything as it is. Then you can see here you have on the line 8 you have the app, which is an instance of this CDK app. So this is pretty straightforward. We have seen that before, and I will just uncomment this. So next we're going to create the variable stack, which will be part of the scope app, and this is pretty straightforward. So you have the variable stack, and then you have new, and then you have the infra, which is coming from the constructs we are defining here, and then you have the scope app, and this is the logical ID. The next thing is we are going to create a variable template which will read from, and in this line 12 you can see we're going to create a variable template, and then this will read from construct that we had imported from the assertion. So this is the template. Now we have to define the properties that we are going to validate. So I'm going to remove this line here, and you can see we have the variable template here, and we had discussed there are multiple methods. So one of the methods is has resource properties, which checks these properties. So if I go here, so you can see the template, and we discussed that template dot from xxx. These are some of the methods, and let's take a look at some of the methods. So one of them is template dot resource count is. So this allows asserting the number of resources of a specific type found in a template. And then you have template dot has resource properties. So this is the one which we are using, where we are checking whether the resource being created has this particular property or not. So that's the one we are using here. And here you can see you have AWS SQSQ. This is more syntax from CloudFormation, because as I earlier said, it doesn't test against the CDK code. It tests against the synthesized CloudFormation template that has been created. Now for this to work, let's first do a CDK synth. Now after running CDK synth, you can see that it's synthesized the equivalent CloudFormation template and it generated this template. So you can see now here CDK out folder has been created. So if I go here and you can go to this infra stack template, and this is the equivalent CloudFormation template that's been created for the code we had written. So it's creating a resource type S3 bucket, and then is a bucket name, then you have the version configuration enabled. So you can see it's in JSON right now, right? If I go back here and to my test folder, okay, where's the test folder? Here is the test folder. So here you can see it is the syntax for CloudFormation. So that is what we have to use. You can just copy it from here for any service that you would create. Equivalent CloudFormation template will be created. So I will just replace this by this. So it's nothing but it will just be AWS, name of the AWS service, and then whichever construct that you are using. Now I have to write the properties here. So it's visibility timeout, it's a boilerplate code again. What I can do is as it tests against the CloudFormation generated CloudFormation template, so I can just copy these properties here because that's what it's going to test against. So I will just copy this from here. And I'll just remove this comment. Okay, this looks pretty good now. If you see, what I have done is here I have again put the two attributes, which is the bucket name, and this is what our bucket name was. If you go here, this is the bucket name, and then you have the versioning configuration status enabled, and we have the version is equal to true. So if you use these, then it's not going to work because it's going to actually validate against the equivalent CloudFormation template that's been generated. So this is how we need to write it. Okay. Now I think everything looks pretty good. So let me just do a clear here. And now let's test. So if I go to the documentation, now the next thing we have to do is run the test using npm run test command. So I will say npm run test. Okay, you can see that it has, this is the name we had given S3 testing. You can see here S3 testing. And then it looks at test suites, one passed, one total. And then it looks at the test, one passed. So we don't have the snapshot test at the moment. We have only the fine grained assertion. So that's what it has tested and passed. Okay, now let me go back to the main stack and say I had this versioning as false. Okay, say I made some changes and by mistake I put the versioning as false, but my organization requires that versioning should be true. So now let's run this test again and now it should fail. So I will say npm run test. Now you can see the test suite has failed because our test mandate, the versioning should always be true. This is how you can actually validate the various properties of AWS resources that you are creating using the fine-grained assertion. In the next lecture, we're going to look at the snapshot testing. Thank you. In the previous lecture, we learned about fine-grained assertion testing, which tests the specific properties of an AWS service being created. In this lecture, we're going to learn about snapshot test. So snapshot tests the synthesized AWS CloudFormation template against a previously stored baseline template. So what it means is once you write the CDK code and synthesize it into a CloudFormation template, then you can define that as a baseline or master template. So next time when you modify the CDK code and make changes and then generate the CloudFormation template, that new CloudFormation template would be evaluated against the master template. So if those changes are inadvertent, you would know and you can fix them. Or if they are intentional, then you can accept the changes and then that would act as a master or new baseline template which would be evaluated against any new templates that are being created. Now let's go through the step-by-step guide to see how we can run the snapshot test. So in the first step, we write the CDK code for AWS service being created with the required properties or attributes. So let's do that. What I have done is I've already created the folder structure by running the CDK init command. Now below the lib folder, what I will do is I will create a new file and let me call it as snap test.ts. I've already written some sample code to generate a CloudWatch alarm when there are any messages in the SQS queue. So you can see here, it's pretty straightforward code. The first thing is we import the core module, then we import the construct, then we import the CloudWatch module and SQS. And then we just have created the alarm with some attributes like we had done earlier in the case of CloudWatch alarm and Lambda function. Then the next thing we're going to do is we're going to write the CDK test and define the baseline or master CloudFormation template against which the new template will be compared. So the first thing we have to do is write the CDK snapshot test and then run the npm run test. So I will go under this test folder and infra.test. You can see some boilerplate code here. So again, I've already written some code. So I'll just show you and explain it to you once I do the paste. Okay, now let me just explain to you what I'm doing. So the first thing is we're just importing the core module again. So pretty straightforward. Then the next thing we do is from the assertion module we had discussed earlier that for testing CDK use the assertion module. In case of the fine-grained assertion test, we had imported the module template, but now we also need to import the match from this assertion library. And then we are importing the dead letter queue that we had created here in the snap-ts, and this is the dead letter queue we had created as a construct. So that we are going to import, and this is from the snap-test file that we created here. So you can see here, this is the assertion module, and here this is the match construct that we need to import. Now this is some, now from the line 6 you can see describe. So this is the name of our snapshot test that we have to define. This is pretty much the boilerplate code that I got from the AWS documentation. You can see here, I'll provide this link as well. So let me describe this a little bit more. On the line 6 you have to define the name of the test. So here we are defining dead letter Q snapshot test, and then you can provide some description, and then you create a variable stack from the stack, and then you define the construct that you have imported. So you have imported the dead letter Q from here. So that's what we provide here. Then you have the scope, which is the stack, this one, the variable, and then you have the logical ID. And then this is again the template that we are creating, which we had discussed earlier in the fine-grained assertion test. And then what it does is it uses the method to match snapshot. So now what will happen is when I run the npm run build and npm run test, it is going to create a baseline CloudFormation template. Under the test folder there will be a snapshot folder, and below that you will have a file which would be the baseline template based on the code that we have written. So next time when we modify this code and make the changes, so now when we run the npm run build and npm run test, what it's going to do is based on the code, it's going to create a baseline CloudFormation template that will be generated, and it will come under this test folder. There will be a snapshot, and below that there will be a file which would be the baseline template. When you run the test first time, it's going to pass because it's going to use the same template. Now if you modify the template second time, it's going to compare against the baseline, and if there are changes, it's going to fail, and it will give you an option also to update the template. So if those changes were deliberate, then you can update the new template as the baseline template. Okay, now let's go ahead and do that. So if I go to the test, so I have to run the npm run test and nps run build, and then it should create within the test folder, it should create a snapshots folder. So let's go ahead and see. So the first thing I'm going to do is npm run build. Okay, I think it ran. Okay, so now I'm going to run npm run test. So it's going to take a little bit of time. Okay, now you can see it has created the test. It's showing pass, and this is the dead letter Q test. This is the name we had given here, and it says that one snapshot written, snapshot summary, and this test pass. So that's what I was saying. that the first time you run, it's going to create that as a base template and it's going to run. Now, if I go to under the test folder, now you can see this snapshot folder has been created, and within this infra.test.ts file has been created. So if I go here, so you can see it is pretty much what we had created, and it gives the CloudFormation equivalent of our code. It creates an CloudWatch alarm, and some of the details have been provided here. So evaluation period 1, metric name, and that's all the stuff. Okay, I need to go under the lib one, and it is the snap test. So these are the configuration details we had provided, and that's what you will see here. So this is the CloudFormation equivalent of that. Now, if I modify the code and then run again, you will see that the test will fail. So let me go ahead and make modifications to my code. So maybe I will add another attribute here. So this is the one. So let me just make some changes. Let me say alarm name, and let me say snapshot test alarm. Okay, I'll just do a save, and now let me just do a clear. And now let me do an npm run build. Okay, I think it ran okay. So let me now do npm run test. And you can see now this has failed. The snapshot has failed because we modified the code, and the base template did not have this alarm snapshot test alarm. So it's deviated from what was our base template. And you can see here when it says one snapshot failed from one test suite, inspect your code changes or run npm test dash 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 u. So that means that if these changes were not done inadvertently and these were changes that were made by design, then you can just run the npm test dash 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 u, and it will update new template as the baseline template. So I will just do that. Now it's going to update that base template. And now you can see it says that this dead letter Q pass, it has passed, and one snapshot has been updated. So the new test or baseline template that would be created would be the one which we have just updated. So hopefully it's clear to you how to run the snapshot test. Unfortunately, there's not been a lot of documentation available from AWS or anywhere. Hope this was clear. Thank you.